type of circuit breaker is usually marked on the breaker itself. Instantaneous trip breakers are typically marked with an I or INST designation, while inverse time breakers are typically marked with a T or INV designation. Here are some additional ways to determine the type of breaker. Instantaneous trip breakers trip immediately when the current exceeds the rated amperage. They are typically used to protect critical circuits that cannot tolerate even a momentary interruption of power, such as emergency lighting and medical equipment. Inverse time breakers trip with a delay that is inversely proportional to the amount of overcurrent. This means that they will trip more quickly for larger overcurrents and more slowly for smaller overcurrents. They are typically used to protect circuits that can tolerate a brief interruption of power, such as motors and appliances. It is important to note that the specific marking conventions may vary depending on the manufacturer of the breaker. If you are unsure about the type of breaker you have, it is always best to consult the manufacturer's documentation. Let's delve deeper into the characteristics and applications of these two types of breakers. Firstly, let's examine instantaneous trip breakers. These breakers are designed for very rapid response to overcurrent conditions. The defining characteristic is their immediate tripping action when the current surpasses a predetermined threshold. This threshold is significantly higher than the normal operating current of the circuit they protect. The primary purpose of an instantaneous trip breaker is to protect sensitive equipment and circuits from severe fault currents, such as those resulting from short circuits. Immediate interruption of power minimizes the duration of the fault current, thereby reducing the risk of damage to equipment, conductors, and other circuit components. Some typical applications of instantaneous trip breakers include the protection of electronic equipment, sensitive instrumentation, and critical control circuits. In these applications, even a momentary overcurrent can cause significant damage or disruption. The instantaneous trip breaker ensures that the circuit is quickly energized, preventing potential problems. Secondly, let's consider inverse time breakers. Unlike instantaneous trip breakers, inverse time breakers incorporate a time delay into their tripping mechanism. The tripping time is inversely proportional to the magnitude of the overcurrent. This means that the breaker will trip faster for higher overcurrents and slower for lower overcurrents. This time delay characteristic is achieved through a thermal or electromechanical mechanism within the breaker. This mechanism responds to the heat generated by the overcurrent. The amount of time it takes for the breaker to trip depends on how quickly the mechanism heats up, which in turn depends on the magnitude of the current. The purpose of the time delay in inverse time breakers is to allow for temporary overloads without tripping the breaker. Many electrical devices, such as motors, experience brief periods of increased current during startup. An inverse time breaker allows these temporary overloads to occur without interrupting power, while still providing protection against sustained overcurrents that could damage the circuit. Inverse time breakers are commonly used in applications such as motor circuits, lighting circuits, and general-purpose power distribution circuits. They provide a balance between overload protection and nuisance tripping, ensuring reliable operation of the electrical system. Furthermore, it is crucial to understand the specific marking conventions used by different manufacturers. While the designations I or INST for instantaneous trip breakers and T or INV for inverse time breakers are common, they may not be universally applied. Some manufacturers may use alternative markings or symbols to indicate the type of breaker. Therefore, it is always best to consult the manufacturer's documentation to confirm the meaning of the markings on a particular breaker. The manufacturer's documentation will also provide valuable information about the breaker's operating characteristics, such as its tripping curve and interrupting capacity. The tripping curve specifies the relationship between the magnitude of the overcurrent and the tripping time. The interrupting capacity indicates the maximum fault current that the breaker can safely interrupt without being damaged. Consulting the manufacturer's documentation is especially important when selecting a breaker for a specific application. The documentation will help you ensure that the breaker is properly rated for the circuit it will protect and that it will provide the desired level of protection. In addition to the markings on the breaker and the manufacturer's documentation, there are other factors to consider when determining the type of breaker. One factor is the physical appearance of the breaker. Instantaneous strip breakers typically have a simple, compact design, while inverse time breakers often have a more complex design with additional components for the time delay mechanism. Another factor is the breaker's intended application. Instantaneous strip breakers are typically used in specialized applications where rapid response to overcurrents is critical, while inverse time breakers are used in a wider range of general-purpose applications. If you are unsure about the type of breaker you have, it is always best to consult a qualified electrician. A qualified electrician will have the knowledge and experience to properly identify the breaker and ensure that it is installed and used correctly. They can also help you select the appropriate breaker for a specific application. In summary, instantaneous strip breakers provide rapid protection against severe fault currents, while inverse time breakers offer a time delay to allow for temporary overloads. The type of breaker is usually marked on the breaker itself, but it is always best to consult the manufacturer's documentation to confirm the meaning of the markings. If you are unsure about the type of breaker you have, consult a qualified electrician. Let's further clarify some common misconceptions about circuit breakers. One common misconception is that all circuit breakers are the same. In reality, there are many different types of circuit breakers, each designed for specific applications. As we've discussed, instantaneous strip breakers and inverse time breakers are two common types, but there are many others such as ground fault circuit interrupters, or GFCIs, arc fault circuit interrupters, or RFCIs, and molded K-circuit breakers, or MCCBs. Each type of breaker has its own unique characteristics and operating principles. Another misconception is that circuit breakers are foolproof. While circuit breakers provide valuable protection against overcurrents and short circuits, they are not infallible. They can fail due to age, wear, or manufacturing defects. They can also be improperly sized or installed, which can compromise their effectiveness. Therefore, it is important to regularly inspect and test circuit breakers to ensure that they are functioning properly. Regular inspection should include checking for signs of damage, such as cracks, discoloration, or loose connections. Testing should involve verifying that the breaker trips properly when subjected to an overcurrent condition. A qualified electrician can perform these inspections and tests. Another misconception is that circuit breakers can protect against all electrical hazards. Circuit breakers are primarily designed to protect against overcurrents and short circuits. They do not protect against other electrical hazards such as electric shock. To protect against electric shock, it is necessary to use ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect small leakage currents that can flow through a person's body and to quickly interrupt the circuit before a serious shock can occur. GFCIs are typically required in areas where there is a risk of water contact, such as bathrooms, kitchens, and outdoor locations. Let's discuss some best practices for working with circuit breakers. Firstly, always to energize the circuit before working on any electrical components. This is the most important safety precaution to take when working with electricity. To de-energize a circuit, turn off the circuit breaker that supplies power to the circuit. Then, use a voltage tester to verify that the circuit is indeed de-energized. Secondly, never bypass or tamper with the circuit breaker. Circuit breakers are designed to protect circuits from overcurrents and short circuits. Bypassing or tampering with a circuit breaker can disable its protection function and create a serious fire hazard. Thirdly, always replace a circuit breaker with one of the same type and rating. Using a circuit breaker with an incorrect rating can compromise the protection of the circuit and create a safety hazard. Fourthly, keep circuit breakers clean and dry. Dirt, dust, and moisture can damage circuit breakers and impair their performance. Regularly clean circuit breakers with a dry cloth. Avoid using water or cleaning solvents, as these can damage the breaker. Fifthly, label circuit breakers clearly. Clearly label each circuit breaker with the name of the circuit it protects. This will make it easier to identify the correct breaker when you need to turn off power to a specific circuit. Use a permanent marker or label maker to create clear and legible labels. In addition to these best practices, it is also important to be aware of the National Electrical Code, or NEC, requirements for circuit breakers. The NEC contains detailed requirements for the selection, installation, and protection of circuit breakers. It is important to consult the NEC when working with circuit breakers to ensure that you are complying with all applicable requirements. For example, NEC Section 240.4 addresses the protection of conductors against overcurrent. This section specifies the maximum overcurrent protection device rating for different sizes and types of conductors. NEC Section 240.21 covers the location of overcurrent protection devices. This section specifies where overcurrent protection devices must be located in a circuit. NEC Section 240.80 through 240.87 provides requirements for circuit breakers used as switches. It is important to note that the NEC is updated every 3 years, so it is important to use the latest edition of the code. The NEC is a complex document, so it is always best to consult a qualified electrician if you have any questions about the requirements for circuit breakers. In conclusion, understanding the differences between instantaneous trip and inverse time breakers, following best practices for working with circuit breakers, and complying with NEC requirements are essential for ensuring the safety and reliability of electrical systems. Always prioritize safety when working with electricity, and consult a qualified electrician if you have any doubts. By following these guidelines, you can minimize the risk of electrical hazards and ensure that your electrical system is properly protected. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. A qualified electrician has the training, experience, and tools necessary to safely and effectively perform electrical work. They can also help you troubleshoot electrical problems and ensure that your electrical system is up to code. Electrical safety is paramount, and taking the necessary precautions can prevent serious injuries or even fatalities. By educating yourself about electrical hazards and following safe work practices, you can create a safe environment for yourself and others. And always remember, when in doubt, consult a qualified electrician.